Today I will start linked list. This is the next biggest topic. Once you know how to use structures, structure pointers, then it's time for linked list. Okay. Okay. Linked list is a linear data structure. Okay. We know arrays already. Set of homogeneous elements. Linked list. Whenever we say list, list means the same. Array is also a list. Linked list is also a list. List means set of homogeneous elements. So this is also set of homogeneous elements only. Both are lists. Array and linked list both are ways of maintaining a set of things, same kind of things. Okay. So in arrays, the set of homogeneous elements are stored in adjacent memory locations. The elements are placed in adjacent memory locations without any gaps. Okay. So when you want to store something in adjacent memory locations, you have to create all of them together. Okay. It is necessary that all the elements are created at a time, because otherwise you won't get the same space again. That is why all of them must be created together. All elements must be created one time. At a time you need to create all elements, means you need to allocate memory for the array as a single bunch. Then you have to also tell how many elements are there in that. And that bunch will be divided into those many elements. Okay. So you need to also know number of elements. Before creation, you have to know that. You have to decide how many elements you are going to have in that array. Number of elements must be decided before creation of the array. Okay. So whenever you create any array, either statically or dynamically, it can be static array, in which you have to tell what is the number of elements. The number of elements you may take as a variable also, but you have to take these many elements at a time. And those many elements are allocated memory as a single set, single bunch of bytes. It will be allocated, and then it is going to be divided into 10 parts. That is why all the elements are adjacent to each other. Okay. So before creation of an array, you must know how many elements you want to create. So once after creating, if it is dynamically created, if it is static, then there is no change. 10 elements means 10 elements only. If it is dynamic, you will be able to increase or decrease. But total number of elements you have to decide, and then when increasing or decreasing also, you have to know how many elements you want to keep. Okay. Insertion or deletion. Suppose this is the data that I am holding already. 5 elements suppose. And all 5 elements have some data already. Now if I want to delete some element from the middle of the array, from anywhere, any existing element I want to delete. Hard deletion is not possible. Soft deletion is possible. What is meant by soft deletion? You can get the effect of deletion, but you can't actually delete it totally. Hard deletion means you have to make it disappear completely. That element 3 should be totally gone, along with its memory location. That kind of hard deletion is not possible. Okay. But you can get the effect of deleting 3 by overwriting this 3 with 4, then 4 with 5, like that. You can shift the data. Then you will get the same effect of deleting 3. Got it or not?
How we can
remove
the 3 element index. Then
how can we remove the index?
I mean, from the list of while you are accessing, if you ignore that element, then.
But if it is not just one element, you have to delete multiple things. Then you have to remember how many elements you have deleted. All those indexes you have to remember in another array. Extra coding is required for anything. Okay. So if you have to delete any particular element from the array, you can't actually delete it. You have to get the effect through programming only. Similarly, if you want to insert anything, if you want to insert something between 3 and 4, or something before 1, or something after 5, if there is space available, then only you can do it. Already 5 elements are there, 5 elements are already filled. Without losing some data, you can't insert anything new. Okay. Even if you want to insert, that is also done through programming only. You can't actually bring a new element and insert. You can only create a hole by shifting the data, and then in that hole you can insert a new data. Okay. Anything you have to do in array that you can do with the data only, not with the memory location, because memory location is fixed already. Okay. So insertion or deletions require extra programming. Extra coding is required. That coding is also a little complex. It's not that easy. Data shifting left to right, that is not so easy. It is going to take lot of time also, lot of time, coding time, lot of execution time also it is going to take. Okay. But when do you want to store any set of elements as an array? When you want to access them, right? When you want to access each one of the element, you want to print them or you want to read the data, that kind of, whenever you want to just visit each element, that is accessing each element. Is very easy because it is just index system. Okay. Just applying the index only, right? In arrays, accessing any element is just in applying the index, which means offset. You have to just calculate what is the address that you want to access and then just get access to that memory location. So here, accessing the first element versus accessing the middle element versus the accessing the last element. If you compare the time, how much time you will require to access the first one or access the any middle element or access the last element, all three are going to be same, because all of them you are simply changing the index. Index 0, index 9, index 100, index 1000. Any index is as easy as just some addition, address addition, and then access the memory location. So it is going to take same time whether you are accessing the first element or the last element. Okay. So accessing any element is going to take same time. Take same time and effort. So this is about array. Array is a homogeneous set of elements. They are stored in adjacent memory locations. If you want to store something in adjacent memory locations, you have to create all of them together. So you need to decide how many elements you want to create. Okay, accordingly memory will be allocated. And then when you want to change this array by inserting or deleting new elements, you need to do lot of coding. Extra coding is required. When you want to access any element, that is as easy as just changing the index only. Any element, first element or the last element, you can access in the same amount of time, same amount of coding. Okay. Now coming to linked list. First of all, what is a linked list? List means set of homogeneous elements only. But it is different from the array kind of list. So what is different in linked list? In array, you have to create all the elements together because they have to be stored in adjacent memory locations. In linked list, that is different. You don't have to create all the elements together because in linked list, the elements need not be stored in adjacent memory locations. And you can create every element separately whenever you need it. Okay, so linked list is, that is why called a dynamic data structure. This is a static data structure. Though you create it using dynamic memory allocation. Even if you create using dynamic memory allocation, it is a static data structure. Linked list is dynamic data structure because you can, on the while execution, you can decide, I need one more element. I need another element. I don't need this element. All these things you can do dynamically. During runtime only you can decide. Okay. So in linked list, you can create one element, then you can create another, then you can create another. All the elements are created separately. They need not be adjacent. They are stored in separate locations. Okay. There may be gaps. There may be random locations. Okay. Maybe this is created first, this is created next, but this is created in between. You can create them in any order. Okay. So when you create this kind of, elements, there should be some kind of connection between them. So when arrays elements, they are already neighbors. They are already attached to each other. They know each other. They all belong to same colony. But here they are all relatives staying in different places. Right? There should be some connection between the relatives. What is the connection? I should remember their contact number. I should remember their phone number if I have to be in contact with them. Right? So there should be some kind of address remembering. Some kind of contact should be remembered by the element if I have to be connected with this. Right? If this has to be connected with this, it has to remember some contact. So that contact is nothing but address here. Here address is simply calculated. Next number, LIG 420, next is 421 automatically. But here it is not 420, it is not 421. It can be anything. Okay, so here address is, calculation is not possible. Like here, address calculation is just +1 here. Here it is not +1. You can't calculate the address. You have to remember the address. Okay, so in linked list, the speciality is every element is going to remember the next element address. Like we remember our relatives' addresses, right? So you need to remember the next element address. That is the link between two elements. So how that link is formed? In the element itself, there is one place, one extra space is provided to remember the next element's address. So there will be a pointer here. If this is your linked list element, in this element along with data, you need one more space also, one more room. There should be 2 rooms minimum. One room for data, one room for storing the address of the next element. Then only these two elements can be linked together. These two elements are now a part of a same set. Okay, so here you can store only data. You don't have to remember any other data, any other thing you don't have to remember. No need to remember address of next element. Okay, so only one data element you can store here. But here just data element is not enough. One data element plus one address part should be there. Minimum 2 parts must be there in a linked list element. Okay, so this next element again remembers the next element's address. This next element is going to remember the next element's address. Like this, every element is connected to the next element. The first element in the array, first element is the base address. First element address is the base address. So in linked list, first element is the leader. You call it the head node. Okay, in array we call all the parts as elements in linked list, they are not called elements anymore. The name is changing. They are called nodes. You have to call each of them. They are also elements only, but we call it nodes in the linked list terminology. Okay, so this is node. 5 nodes are there. The first node, you have to remember this separately. What is its address? Because for this entire linked list, this is the leader. You have to remember always the leader. If you remember this leader, then only you can have access to the remaining elements of the group. Okay, so in array, we remember the base address always. Here also you need to remember the head address. So this is your head node, and its address you have to always keep handy. You should never lose that address. If you lose the head node address, you lose the entire list. And every node is going to remember the next node's address, whereas the last node, this is the last node simply, this will also have the same part. These are all homogeneous elements. So every node will have the same 2 parts. So in this, there is data part, there is already address part. If you have next node, it will remember that address. If next node is not there, then it will remember a null. It has to still fill that pointer. Address means pointer. You can't leave the pointer without filling. While it will become wild pointer. So you have to fill it with 0 at least to indicate that this is the last node. This is the linked list. This is how we create a linked list. Okay. So linked list is a set of nodes. All the nodes will be of same data type. Okay. And the first node address we have to remember separately to remember this entire linked list. Okay. And every node will have two parts, minimum 2 parts. You can have more than 2 parts also. But in the 2 parts, one part you can have data. That data can be any number of parts. You can have ID, you can have name, you can have any other data elements that you want to have. But the other part will always be for address of the next node. It has to always remember the next node address. Means it's a pointer member. Okay. So every node is going to remember the next node address like that. Fine. When you go to the last node need to be indicated that this is the last one. Okay, how you will indicate that this is the last node, because last node does not have any address to remember, so it will put a 0 in that pointer. It will be a null pointer. Then that means it's the last node. Okay, and all these nodes are created whenever you want. During runtime only, you can decide first element you have to create first. Okay, I have head node, only one node. After some time you can decide I need one more node. You can add one more node. After some time you can add one more node. After some time you decide I don't need second node, you can delete it. Here hard deletion is possible. Hard insertion, hard deletion is possible, unlike array. Here you once decide the size 5, it will be 5. Maximum you can resize it to some other number of nodes, but you can't actually insert or delete anything in between. But in linked list that is possible, because all these are randomly located. They are not adjacent to each other. So you don't have to shift any data. What you can do is, if you want to insert something, create another node somewhere. You just have to change the links. I want to insert this between these two. Insertion is not directly inserting it in this space. You can create it anywhere, but you have to make that this node remembers this node address, this node remembers this node address. You have to change just the memory you have to change. That now remember this is your next node. Then it will keep this node's address. Then this node will keep this node's address. Now the list is changed with the new node inserted. Similarly, you can also delete. Deletion is also simply now remember this node's address, and you can simply release this. Okay, so that kind of insertion or deletion at any place in a linked list is possible. Right? Not stored in dynamic, adjacent. Not stored adjacent. Any node, every node can be created separately. when we need it. When you need a node, at that time only you can create the node. So why it is called dynamic data structure? This is the reason. Because during runtime, you can simply create a new node, you can add another node, like that the size of the linked list is going to expand or shrink. During runtime, you can simply increase the linked list size. You can decrease. If you don't want to keep, you can delete. But array size, you can't do like that. So many times resize, reallocation. Real is possible if it is dynamic, but if it is static, it is not possible. But even in realloc, you will not just create one element. Every time you have to tell the entire size. In linked list, it's not, you don't have to bother about what is the entire size of the linked list. You will always work about only one particular node. Create one node, delete one node. Entire linked list, you are not bothered. How many elements are there in the entire linked list? That's not our issue. Okay. Then, number of elements must be decided. No need here. You don't have to tell how many nodes I want to create first. You can just start with one node, then keep on adding whenever you need extra nodes. Okay. Number of nodes need not be decided before creation. Can just start with one node and can go on adding new nodes whenever required. That is why this is called a dynamic data structure. And this linked list, if you want to create a linked list, you have to completely depend on dynamic memory allocation. It can't be done with static memory allocation. Because you want to create a node during runtime means you have to allocate memory dynamically. You can't declare variables during runtime, right? Static memory allocation is variable declaration. Okay. Now insertion or deletion. Insertion or deletion in linked list is very easy. If you just have to find out where you need to insert. That node you need to find out where you have to insert. And once you know, it is simply changing the links only. Deletion also same. Which node you have to delete. That address if you find out, you can simply delete it very easily. It is possible without shifting the data. You don't have to copy the data here and there. You just have to release the memory if you want to delete, insert or create a new memory if you want to insert. Okay. So it is easy in linked list. Can be easily done. But accessing the nodes in a linked list is not so easy like in array. Why? Because in array, if you are given the base address, you can simply apply 999 index and simply go to 1000 index in the same time as 0 index. There is no time difference. Just changing the index, it is very easy. When you come to linked list, what happens? You just have the head node address. If you have head node address, going to second node is access the head node's pointer, which is remembering the next node address. You have to get this address first. Using that address, you have to go to this node. Okay. Again, if you want to visit this, you have to go to again head node only. Go to head node, get the second node address, go to second node, get the third node address, then go to third node. If you want to visit nth node, again you have to start from head, get the second node address, then third node address, get the n-1th node address, then get the nth node address. Okay. So in order to visit any node in the linked list, the time taken is proportionally increasing with the distance from the head. If the head node is your visiting place, you can directly visit. But the second node, you have to take 2 steps. Nth node, you have to take n steps. You can't directly go to the nth node. Without visiting head and all before nodes, you can't directly go to the nth node. That is the problem with linked list. Okay, that is the time taken visit any node depends on its distance from head. Head node. There are different types of linked list. There is double linked list, single linked list, circular linked list. Whatever is the linked list, same problem. Because you have to always start from head only. Here you don't even remember how many nodes are there. In array, we have to always remember how many elements. Because for any kind of access, if you go for a loop, you must remember what is the higher limit of the index. Here you don't have to remember how many nodes. What you do is simply go on visiting till you find a null. This is like your string. Till you find the null character, we can keep on visiting the string, right? So here also, you can keep on visiting the linked list nodes till you find a null. The time taken to visit any node depends on the distance from head node. So the time taken to visit the first node is very minimum. Second node, 1 step extra. Nth node, n steps extra. Okay, so to visit nth node, we need to go through all n-1 nodes before. Directly going to nth node is not possible like in array. To go to fifth element in array, you don't have to go for 0th element, first element. You don't have to visit all 4 elements. You can directly go to the 5th element. Array of 4. Here it is not possible. If I want to visit 5th node, you must visit first node, get the second node address, second node, get the third node address, then only at some point you will be able to visit the 5th node. That is the problem with linked list. Insertions and deletions are very easy in linked list, but accessing the node is problem. If for insertion or deletion also, you need to first access any node. Okay, but still it gives you the flexibility without resizing the entire array. Here you need to resize the entire array. Here you don't need. Just to create another element, you can easily link. But first you need to access. Right? So in array or linked list, array is not dynamic. You can't change it during runtime, but linked list you can increase or decrease the size during runtime. So linked list is going to give you a lot of flexibility, but with extra coding only. You have to write a lot of code also. Array is a built-in data structure. Array linked list is not built-in. You have to write a program to create a linked list, use a linked list, everything. Every linked list operation you have to write a code. Array creation is already there. You just have to declare the variable. Already it is created. Got it? But array does not give you the flexibility of linked list. Everywhere it is not possible. Everywhere array cannot be used. Some places you have to go for linked list. So where you have to go for array, when you know that a fixed number of elements are going to be there, you don't have to insert or delete anything. You just have to keep on accessing them. Then you will go for array. But when you have to keep on inserting or deleting something, then linked list is the option. Right? So in your device drivers, you will be using linked list mostly. These are the differences